Alrighty. Gonna try this meta question here. It's something I've done before, but I haven't done the problem in quite a while. Also don't have any submissions here. I'm gonna time it and try to solve it within 25 minutes. Hopefully we can do that. Okay. So, 236, lowest common ancestor of a binary tree. Given a binary tree, find the lowest common ancestor of two given nodes in the tree. According to the definition of LCA on Wikipedia, the lowest common ancestor is defined by two nodes P and Q as the lowest node in T that has both P and Q as descendants, where we allow a node to be a descendant of itself. Right, so given this tree here, we're gonna have 3, 5, 1, 6, 2, 0, 8, 7, 4. P is gonna be 5, Q is gonna be 1. Our output is gonna be 3. The LCA of nodes 5 and 1 is 3. Another tree, we're gonna do 5 and 4. The LCA should be 5, right? So our goal here, just to ensure that we're on the same page, is find the node find the lowest common parent node of two nodes P and Q. Find the lowest common parent node of two nodes P and Q, right? I think that's a good way to put it. I'm tired. Okay, clarifying questions. What would I ask here? Before looking at the constraints, because let's say it's interview, we don't have constraints. Are P and Q guaranteed to be in the tree, right? Because if they're not, does it really matter? I don't know. Are we always given a valid tree? It's given a valid tree. And I can assume our tree nodes are val left, right. What else would we ask that's important? What else can we ask that's important? That's what you need to know. All right. I think that should be all. Now let's add the constraints here. Constraints tell us the number of the nodes in a tree range from 2 to 105. So that means at least 2 nodes in a tree. P does not equal Q, and P and Q will exist in a tree, right? All nodes values are unique, and we're going to be 0 of 10 to the 9th all the way to 10 to the 9th, right? So what should be our like high level strategy or general idea? Given us a tree, we really just have 2 options in terms of searching the tree. We could do a breadth first search or a depth first search. I'm not aware of a way that you can solve this problem using breadth first search, but I'm sure there is a way. I am give me a second to think here. I mean, there probably is some way to do buffer search. Um, Store what level each node is on. We're going to find P and Q, figure out what level they're on, and then try to find whatever height. If we just take like the minimum height, I feel like that would work, but that just seems messy to me. Here, what do we need to know? What do we need to know in order to get a solution? All right. So we have a couple of ways that we can have at least come Ancestor, right? They can be in separate subtrees, right? They can be separate subtrees. In the same subtree, different levels, and then one can be a direct descendant of another, right? So what do we need to do to find it, right? So let's just take the tree 3. That's gonna be we'll just take 3 5 1. 3 5 1. All right, we have 3 5 1 here. If P is equal to 5 and Q is equal to 1, right? Our LCA is equal to 3, right? If P equals 5, if P is equal to 3 and Q is 5 or 1, it's still 3, right? Direct descendant and others. So in order to find the LCA, we need to find both P and Q, right? P and Q. In order to find LCA, we need to find both P and Q. So let's do that, right? We need to search. So let's write down some steps here. We're going to use some sort of DFS helper. Our base case is going to be if root is equal to null, return null, right? If we find P or Q, return it, right? That makes sense, right? If you find P or Q, just return it, because that means to be or Q, return it, right? We return it because we need to find it. So let's write that down real quick. As root is equal, no, let's not do that. So if root is equal to P or Q, return it, right? So if we don't find, we need to recurse on both and right subtree. So if we don't find, we need to recurse. What do we return when we don't find it? If we don't find, return null. right? Because it doesn't matter. We're only looking for P and Q. Um, so we're gonna have like left is equal to DFS.left, right is equal to DFS.right. All right. If we don't find, return null. If they're found, left or right is equal to P or Q. All right? That's the only options we can have, right? Because if it's null, we know we haven't found anything. They can only be P or Q because we're just going to return null any other time. So what happens if one of them is P or Q? So if left does not equal null, that means we found P or Q. We need to find the other. If, all right, hold on. If they're both null, if they're both not null, what does that mean? That means we're at the LCA, right? They're both not null, that means we're at the LCA. Because it means we're at the LCA, right? If we're both not, we're at the LCA, right? Because let's say if we're using 5, 1, right? 5 is going to return 5, 1 is going to return 5, 3 is going to return in this recursive step, 3, it's going to recurse to the left. That's going to find 5. It's going to return 5. And then when it goes right, it's going to find 1. That means we're at the LCA, right? So means we need to find the other. So if left does not equal null, we're going to return right. All right, so if 1 is null, return the other. So let's use this example here with 5 and 4. So 3, we're going to go left. Left, we return. Now how do we get to 4? So we need to do a post order. So base case is equal to null. We're gonna do a post order. Post order because we need information from our subtree, right? Root is null. Base case, we just recurse right and left. Go left and right. Right, so now we go here, and go left, left. All right, it's gonna return null. 5, it's going to return 5. So we're going to do a post order because we need information from our sublanes. Go left and right. We're going to hit a leaf or P or Q. Or P or Q. Those are only options, right? So we're gonna hit a leaf or P or Q. If root is equal to P or Q, return it. Right? So then left and right can only be P or Q. If they're both not null, that means we're at the LCA. If one is null and if one is null, return the other. We found P or Q, we need to find the other. Yeah. Okay. This makes sense. So basically go left, we're gonna hit a leaf, P or Q. If one is null, return the other, means we found P or Q. So what does that look like? Let me code that up real quick. So if root is equal to null, return null. Tree node left is equal to root dot left PQ. Tree node right is equal to root dot right PQ. If root is equal to P or root is equal to Q, we're going to return root. All right. So now, if left does not equal null and right does not equal null, we're also going to return root. So we're just going to put that here. Right. So if root is, so if we find one of the things we're gonna if we find P, if we find Q, we're gonna return those. Else, if we've already found them, we're just gonna return the root, right? And then no, so if left is not equal null, return left, right? Else, if left is not equal null, right? If right does not equal null, return right. Oops. Return right? And then, if all else fails, we're at our fall through, which is return null. Means we haven't found it. But this says P and Q will exist in tree, so we'll never get here. This should be it, right? So let's see. So let's do 5 and 4 here, right? So DFS 3, not null. Left is equal to 5. Right is equal to 1, right? So we're gonna go left. So DFS 5. Left is equal to 6. Right is equal to 2. Want to go left again. DFS 6. Here, left and right is equal to null. DFS 6 returns null. Now we're going to go back to 5. We're going to go back to 5, but this time we're going 2 path, right? So then put it up. Let's put it up. All right, so DFS 2. Left is equal to 7. Right is equal to 4. I'm going to go DFS 7. Left and right is equal to no. DFS 4. Left and right is equal to no. Nothing happens here. Oh, no. I'm sorry. I'm tweaking. DFS is equal to 4. We've found DFS is equal to 4. Left and right. Is equal to no. However, root is equal to 4, so we return 4, right? Right, so now we're at two with 7 and 4 completed, right? 7 and 4 done. Left is equal to no. Right is equal to 4. Alright. So root right now is 2. Left is not equal no. Left is equal to no, so it's gonna go and then it's gonna return right. So then DFS, this is gonna return 4. Alright, so now we're up to DFS 5. Left is equal to no, right? Right is equal to 4. In our combined conditional, P is equal to 5. So we're going to return 5. We're going to short circuit this. This is going to return no. Just to save us some time, return 5. Then we're going to get to the end where DFS left, DFS 3, where left is equal to 5, right is equal to no. We're going to return 5. And that's the answer. That should be it, right? Let me make sure I have this good. Ha! Good job. So I've done it in about 23 minutes. I think my explanation was pretty bad. I'll work on it, but at least I got it.